Welcome to homework.
Problem. So that is the inclined plane. So this is the angle or inclination that we need to find. And here is the cube. And the center of the cube, let's say that's here. Now we are given that the length of the cube is 2 meter and CG or the center of gravity is 18 cm above the center of the cube. So 18 cm from this point. Now this is a diagram for the crate on the verge of tipping. So now let's draw the forces acting. So let's write this distance first. So this is half of S. So this is 1 meter. And the center of mass is 18 cm above O. So somewhere around here. Sorry, this is the center of gravity. And this force should be equal to mass times acceleration due to gravity. And since this distance from the base to O is 1 meter, therefore the center of gravity is above this plane by a distance of 1 meter plus 18 centimeter or 0.18 meter. Therefore, this distance is 1.18 meter. Now, from the textbook, figure 12.12 and the associated discussion, you will realize that if a vertical line projected downward from the center of gravity falls outside the base of support, then the object will topple. This means that if you draw a vertical line from the center of gravity, so let me just project this. So if this falls, so if this goes like this vertically, then it's outside the base of support. In this case, the object will topple. If it is inside the base, then the object will not topple. So for the limiting case where the object is just on the verge of tipping, the vertical line from center of gravity, basically this force, should pass through the edge of the base of support. This means that if you project this line, it should exactly cross this edge. Now any more tilting and the gravity would cause the block to tip over with the axis of rotation through the lowest corner of the grid, which is this point, the edge. Now that we have the a triangle with all the dimensions, we can find theta using these variables. So since this angle is theta, the angle here should also be equal to theta. Now as you see, this is a right angle triangle. Therefore, tan theta, when the object is just about to topple, in that case tan theta will be equal to 1 meter, which is the base, which is the perpendicular opposite to theta over the base, which is 1.18 meter. And this gives theta, oops, equal to tan inverse of 1 over 1.18, and this gives theta to be 45 degree, which is approximate to two significant figures. Now the other forces on the block, such as the normal force from the plane on the block and the frictional force, would be acting at the lower corner. And so basically from here, so all the normal forces and the normal force and the frictional force, when the object is just about to topple, would all be acting at this edge or this corner of the block. Therefore, since we are taking the torque about the lower corner, they won't cause any torque about this lower corner, because they will be passing, the forces will be passing through this corner. Now the gravity force causes the tipping, because that's the only force that has component of force that gives the torque. So basically, if you take mg to be like this, you'll get a torque. Now, if it wouldn't matter if the block is static or sliding, since the magnitude of the frictional force will not enter into calculation, because the torque due to the frictional force will be zero about this corner.